Hey everybody, we are working on lesson 5.3b today, which is graphing the sine and cosine functions. These are what the graphs look like. We're going to build up to this later on, but we're going to go ahead and start by looking over here at our unit circle. This is a very simplified version of the unit circle, but it has kind of those four main points that we have on our unit circle: the 0, the 90, the 180, and the 270. Remember when we made our unit circle, one thing that we learned, and we wrote this at the very bottom of the page, is that on every point on our unit circle, the x-coordinate is our cosine value at that angle, and the y-coordinate is the sine value at that angle. So we are going to start by making a table listing the sine and cosine values at these four angles. So we have theta for our first column, then sine, then cosine. So the angles we're going to use are these four, but I'm going to use the radian measures. So this is 0, pi over 2. Then we got pi, 3 pi over 2, and 2 pi. And I can look at the coordinates to fill this in. So the sine value at 0 radians is 0. The sine value at pi over 2 radians is 1, then 0, -1, and back to 0. The cosine values are x coordinates, so 1, 0, -1, 0, and back to 1. So one thing you can notice is that these are just all the same numbers repeated over and over again. And also there's a 0 between every single one, and that's going to impact our graph. So let's take a look at the sine graph first. You see here is y equals sine of x. So the sine graph starts at 0, then goes up to 1, passes back through 0, -1, and back to 0. The cosine graph starts at 1, 0, -1, 0, 1. All right, so these are the parent graphs of the sine and cosine functions, but it looks like they're very different when you look at it here. But I want to show you that they're actually basically the same. It's just that what we have here is one cycle of those graphs, but we actually have, infinitely many cycles when we do periodic graphs. So here is the sine graph, and the second one is the cosine graph. So we can see that the sine graph, let me get a little closer here, starts at 0. And then we do our max, 0, min, 0, max. The cosine is the red graph. So it starts at the maximum, but it still follows the same pattern as the sine graph. So both of these are bouncing between their maximum points and their minimum points, and they're passing through 0 in between every single one. Okay, so you can see they look pretty different here, but they're not really different. It's just that we have a little specific slice of each one. All right. Now, when we're graphing sine and cosine, of course, we're going to have some transformations with these. So we've got this parent function right here that has, well, not the parent function, I should say, all the transformations of these functions, which is opposite of the parent function. But we have lots of variables in here. So we've got our x and our y, but we also have a, b, c, and d. Now, c and d are going to come up in the next lesson, but today we're going to talk about the a and the b. So the A is the amplitude of the graph. And we learned about amplitude in the last lesson. B is the period of the graph. We also learned about period last lesson. So that's the length of one cycle. Now, if we look at this little video here, it shows you one complete cycle of this one's the sine graph. And you can see it's just kind of following the distance that the radius is away from the origin. You see that? I'll go ahead and play it again. Oh, it's not letting me. Anyhow, but you can see there that one cycle is one complete rotation around the circle. We could also see that in our table here. So we start at 0, then over to 1, and then 0, and then -1 back and 0. That's one full circle. So one full circle is one cycle of this graph, of both of these graphs. So for that reason, the period is equal to 2 pi as the default. So our parent function, the period is 2 pi because that's one trip around the circle. But if there's a number here, a b value here, we divide that by the b because it can be kind of squished up shorter or stretched out longer. I'll show you some of those in a minute. Okay, so let's go ahead and take a look. I'm just going to play with my calculator a little bit. So let's say instead of just sine and cosine, we'll leave the sine on there, and I'm going to try a different period. So let me try sine of 3x. All right, so we already have sine of x here. This is the blue one. 3x looks like that. So when I do 3x, what that means is we're going to squeeze 3 cycles in the space that it takes the normal sine curve to do one cycle. So I'm going to adjust my window a little bit. I'm going to make my x maximum 2 pi because that's one full cycle of the regular graph. So this is going to stop at 2 pi. That's one cycle. Now, if we look at the red one, starting at 0, it completes 1, 2, 3 cycles in that same distance. So that's what having a b value does. Now, the other thing that you could do is, let's say I do 0.5x. So what this means is we're going to complete half of a cycle in the space that we would normally complete one. So again, here's one cycle at regular sine of x, and you see that? It's like half of a cycle. If I change my window and I make it a little bit longer, so instead of going out 2 pi, I'll go 4 pi. So we should get 2 cycles of the regular one, and now we're getting 1 cycle of the 0.5 pi. All right. So B either, it's like almost like a horizontal stretch or compress. Okay, so let's go ahead and jump in and do some actual graphing. So looking at number 1, excuse me. So we got sine of 3x. So funny, I just graphed that. Didn't even do it on purpose. Let's straighten my paper here. Okay, so we've got sine of 3x. So the amplitude is if there's a number in front of the sine or cosine, that would be your amplitude. So there's no number here. So we're just going to have our parent graph amplitude of 1. But we do have a period and there's a 3x there. So remember that the period is equal to 2 pi over b, and 3 is the b value. Now, if you can simplify this, you should, but we can't simplify 2 pi over 3, so we'll just leave that like that. So when we make a sine graph, we know we want to start at 0. Our amplitude is 1, so that means from the center of the graph, which is our x-axis, we are going to go up 1 and we are going to go down 1. Now, if you would like to draw little dotted lines across here, you can, because those are going to be your max and your min. You don't have to do that. I don't think I'm going to. Now, the period being 2/3 pi, 2 pi over 3, what that means is we need to complete one cycle between 0 and 2 pi over 3. So luckily, I get to create my own scale here. So I'm just going to say, hey, I'm going to say 2 pi over 3 is right there. But I need to divide it up because there's kind of 4 sections to these graphs. So I'm going to split this into 4, which means I'm first going to mark the middle. And we do want to label this. So halfway between 0 and 2/3 pi would be 1/3 pi. And then I'm just going to put little markers halfway between each of those sections. So now I've got 4 sections here. I also want to label 0 at the origin. The directions for this section say make sure to label the X and Y axis in at least 3 places each. So because 0 is at the origin, it counts for the X and the Y. So I've got my 3 labels. So now I'm ready to create my graph. I'm going to use the table that I'm looking at up above. So we start our sine graph at 0, 0. Then we go, it says pi over 2, 1. But what that means is, in this context, we're going to go over to the first mark I made, and that's where our max is going to go. Then the next point is at 0. Next is at -1. And then back to 0. Now, when I connect these dots, I need to make sure it's a curve. We have a picture of what the graph should look like up above. So you want to try to make sure it looks kind of like that. Let's see how I do. Pretty happy with that. There we go. I'm always happy to assist. Okay. There we are. So that is your first sine graph. Hopefully it made sense. Now we're going to move on to number 2. It's another sine graph, but this one has an amplitude change. And it also has kind of a messy B value, so we'll get into that. First, I'm going to go ahead and fill in my little chart over here. So the amplitude is 2. And for my period, I have to do 2 pi over 1/4. So what I do to simplify when I have a fraction in the denominator is I like to multiply the top and bottom by the denominator of that fraction, because 1/4 times 4 is just 1. So I can cancel that out now, and I have 2 pi times 4, which is 8 pi. Okay, so now I'm ready to set up my axes. So the amplitude is 2, so I'm going to go up 2 and down 2. And the period is 8 pi. So I'm going to put 8 pi at the end. Halfway to that, it would be 4 pi. And you could label these, like that would be 2 pi, that would be 6 pi, but you don't have to label those ones. The requirement is 3 labels. I've got 3 labels. And after this, I'm going to graph it the same as what I graphed before. So we're going to start at 0, 0. And then next we go to the maximum, back to 0, then the minimum, and then back to 0. There we go. Now, one thing you'll see here is that these two graphs look exactly the same. The only thing that is different about them that kind of distinguishes them from each other is that they have different markings on their X and Y axis. And because we're choosing our own scale, we can kind of make that happen. We can make them look the same, even though they're very different. So let me show you what these graphs actually look like. So I've got sine of 3x, oops, sine of 3x, and I've got 2 times the sine of 1/4 x. I'm just going to do 0.25. I hate it when the lights turn off. Okay, so, and I've already got this set up. I think I've got it set up out to 4 pi. I don't know, we'll graph it and see what it looks like. So that's the first one. That's your 3x. That's your 0.25x. So you can see how different they look. Now, remember, this means we completed one cycle between 0 and 8 pi. So if I change my window to where my X max goes out to 8 pi, we're going to get one cycle of the red one, which is number 2, and lots of cycles of number 1. Okay, so just kind of keep that in mind when you're making these graphs, is even though they look on here like they look the same, they don't really look the same. Okay, although I'm noticing something here. This one has an amplitude of 2. This one only has an amplitude of 1. Yeah, the 2 didn't go in. Let me fix that. There we go. There's our amplitude of 2. Okay, so again, these look like they're about the same height, but notice on this one, I put 1 and 1. On this one, I put 2 and -2. Well, if we put them on the same space, we can see that number 2 is definitely taller and goes down further below than number 1 does. Okay. All right. Moving on. So now we're going to do our cosine graphs. So the first part is exactly the same as the sine graphs. We just need to fill this out. So the amplitude is 4. The period, we have a b value of 4. So we're going to do 2 pi over 4, which is going to be pi over 2. So my amplitude is 4. So we're going to go from 4 to -4. And pi over 2 is the end of my cycle. So halfway between 0 and pi over 2 is pi over 4. Now this is a cosine graph. So the cosine graph starts at the maximum. So I'm going to start here. After that, I follow the same pattern as sine. It's kind of like I'm start right here. So then I come down and then back up. So I'm going to go through 0, then down to my minimum, back up to 0, and back up to my maximum. All right, let's do number 4. So number 4 is a 1/2 cosine x. So the amplitude is 1/2. Now there's no b value, which means the period is our standard 2 pi. Okay. Amplitude's 1/2. So I'm going to try to make this one look a little different than the other one. So if I were to say this is 1 and -1, then my 1/2 would be here, right? So I'm just going to make it a little shorter than the average graph. One thing you can do to help you remember like where your max and min are, if you don't put them at the top and the bottom, is you could just draw a little dotted line like that to keep you in the right place. So now we're ready to graph. We started at the max, 0, min, 0, max. There we go. Kind of missed this one at the bottom, didn't I? I was like, there we go, better. All right, so that is the end of your introduction to graphing sine and cosine. And like I said, the next lesson, we're definitely going to dive deeper into it. You guys are going to learn about what this C and this D do to the graph. Based on your history of graphing in this class, you might already have predictions for that. So stay tuned and see if you're right.